causation of checks and the type of splits and cracks that occur during lumber drying. And there's only three categories in it. First, you're going to find here is surface checks. You're going to find end checks and splitting, and internal checking, or what's called honeycomb. So when we look at NAFMA, for example, and we're looking at NAFMA will, in their clear grade oak, they will admit character such as small, tight checks. So when we start asking ourselves, as far as in grading of material, on what we sell today, I would say is probably between 70 and 80% of character grade material. Well, character grade material is, if clear has checks, you're going to find your character grade material also has checks. And when you look at far as checks being a defect or part of character, for example, like in your character grade material, that would be part of that character of that material, where you'd find something like here it says a tight check in clear material, and if it was an open check, that would be classified as a defect. When we start asking checks, what are they? Why does this happen? When we start looking at when this log dries out, is there a difference between a split and a check, and what causes them? So as we look at this log here and seeing it, we've seen that time and time again, whether it's on 2x4s, 2x6s, on poles, you'll always see the material will split, is what you see here. In getting into is the shrinkage of it. We'll find like in the shrinkage here, the greatest and the longest growth rings in your tangential here. Then you get the shrinkage at least across the growth rings is here. And then you'll also get where the little shrinkage is along the length. Very little you'll find that material will shrink in length. And so when we look at how does that respond when we start asking ourselves environmental effects. Now we look at the log here. Now when you look at a plain sawn material, that is going to cut when we start looking at environmental change. You look at that same, out of that same log, when it dries, we can take and showing here it in rift and quarter sawn, it doesn't cut. It pretty much remains flat. So if we're going to take and specify a product, kind of like what they did in Versailles, France, that we ended up, what did they most likely use? Most likely they used quarter sawn material because of the stability and the lack of improper controls. So it's good knowing what you're selling. Will that plain sawn floor work in a cabin up north? Most likely it will, but it's going to be experiencing cupping. So it'd be important to know what areas of what species, what type of grain cut it is, and how it's going to perform. When this happens, we're going to go, and you're going to see the wood will shrink 2.5 times as much tangentially direction than you will in the radial direction. And when you look at this, no matter how we try stopping that log, we cannot physically stop it from splitting. And the reason is because, as we saw here, it's going to shrink 2.5 times this, or 2 times this direction, as opposed to only 1% this direction. So here you're looking at when this shrinks, it's going to split across the grain as opposed into our radial direction. We can't stop that no matter how we try to do it. It's just the dynamics of the log. So when you start asking yourself, far as in the predictability, what we can predict in shrinkage is only 0.1%. So in our length, we only have the 0.1%. When you look at your radial direction, so you look at your radial, and that would be this direction here, and that's only 4%, and tangential is 8%. So when you start looking at this slide back here, that's why you're seeing that this shrinkage compared to your radial direction here. That's why it's understanding and knowing where the material is going and the importance of it.